All right, so it is Friday, the 19th of May. And mine is pretty short today. I don't know if I posted this in Slack or not, but I thought this was super cool. This many terabyte model, 16 terabytes of imagery used to recreate a model of the Titanic. I think that's so good looking.
Just so cool.
I didn't go far enough to figure out if we can actually like explore it. I imagine so, right? Like, is it up? Did anybody try it?
I didn't try it.
Yeah, it'd be interesting to see if that's navigatable. I met with Rebecca on Monday. We're getting that project started back up again for the summer. She's just going to be working part-time on it. The Google XR Geospatial Creator is pretty cool. And that was just released a couple of days before the last week's lab meeting. So she's going to do a little looking to see how we get started, even just using it at all. And then my hope is that because it's in this OGC 3D tiles format, that we can actually bring in a Google Earth VR model into what we've done already. So that would be really cool if we could have the ability to navigate that VR cloud. I don't know if it's going to cost money, probably, but we'll just have to see. We never did get the LAZ exporting finished with that. It can export CSV, but not LAZ, so we need to do that. And then just a simple sort of navigation task. We need to improve sort of our ability to navigate in there and move and manipulate the cloud, just spatial, just like moving it around or moving ourselves around. So we need to position the cloud so that it's flat, among other things. So a couple of tasks for her this week. The deep learning run for Roanoke completed. So the last time I presented the training on 2021 and then applied to 2021, so sort of a bit of a cheat. This is 2019 imagery, 2019 data applied to 2021, so a whole different model. And I would say it performed equally as well. The other method, training on 2021, is actually not so bad, because when they get the 2023 imagery, which I don't know if they have it or not, they should be able to train. If they wanted to make a new model, they could just take the polygons that they have and then train it on that and then apply it. Our models are also portable, so I'm going to meet with them, I think, on Monday, and I'll give them the 2021 model, and then they should just be able to apply that to 2023 without needing to train it at all. It does take about a week to do the training because it's such a lot of imagery. I imagine you could cut that down a little bit, right? Like, we're training on all of the polygons and all of the image for the whole city. Probably not necessary, but also very little work. Just a couple of clicks to sort of get it going, rather than sort of like spending a couple of hours like carving it out. So probably fine overall. This is one I'm hoping to get some feedback from you guys. The model runs for the baseball diamond with the FLIR Duo R, which was twice the resolution of the one that we bought as part of Lindsay's project. Lindsay's, that camera was 320 by 240 or something, and this one was 640 by 512. So the high resolution models definitely do, they are better. So I'm pretty convinced that you should try to get the highest resolution thermal camera that you can get. The 320 was fine, but I think this is better. The bigger question that I wanted to get some feedback on is like, why or when 3D? And actually, I found this really great article that I'd forgotten about, but one of the master's students at NIU, when I was there, had done a pretty nice little study on 3D versus 2D. And it's kind of an interesting topic within cartography. So I can go back and sort of look at the literature on that, and I need to do that. But why? What is it? Is there anything about thermal that we learn when we look at a 3D image versus like an orthographic image. So I've got the same, these could be prepared a little bit better, but the gist is here. This is sort of a map-like view of the environment. And this is sort of a perspective view of the environment, which we can also animate. But the bigger question is why? What's the point? So I've made a couple of notes here. One, perspective is natural. You know, humans aren't really used to seeing the map-based view. I mean, we are because we're exposed to maps all the time, I guess. But it's a little bit less familiar. I remember I had done a drone scan of my family farm, and I showed it to my grandmother who had lived there for like 40 years, and she was like, "What am I looking at?" I think we get used to, we geographers especially spend a lot of time looking at maps and satellites and all kinds of stuff, and we forget that not everybody does that. So I wonder if these images connect with people a little bit better than these do. The animations are engaging, so just the motion kind of gets people interested. That has its own value. I'm making a point here that I'm willing to be open up for debate. I would argue that there's a little bit more information than top-down only, because you're seeing the sides of things, so that's giving you an extra perspective about what's going on there. Is it a lot more? Maybe not. We could measure that. We could look at things like entropy in the image to try to like categorize like how much information is actually there. But I think that's probably true. And then kind of speaking to that, what do you learn from this that you don't? What do you learn from this kind of thermal imagery, high res drone based thermal imagery that you don't get? One thing that I get is that dirt is almost as bad as cement. So this is the baseball diamond. This is the track. The track obviously shows up bright red. You would expect that. But the infield on that baseball diamond is also not great. And this is kind of like a big construction area. This is just like bare dirt. So bare dirt is pretty bad. And then grass is not as good as you might think. It's kind of in the scope of this scene, this is sort of, middle, and the trees are definitely on the cooler side. I included the histogram down here because I think it's kind of interesting how trimodal it is. Like these ends pop out in an interesting way. I don't know if that's a real thing or what, but I know you guys have seen a lot of these images, but I'm just interested in feedback. Like,
I'm not very sold on the 3D.
you're not.
Yeah, because I just think the only thing that 2D lacks is context. And if you have contextual maps besides it, it would do everything the 3D does.
Contextual maps, like, can you give me an
Right.
example?
In the 2D map, the major problems I had was I did not know what was what, like the building, like the small part, I could not differentiate it from anything else
Mhm.
if I did not know the place. And the trees look like smudges, they don't stand out to me. The baseball diamond does not look like a baseball diamond.
Over here.
Yeah, so everything looks like smudges in the 2D because I think it's the property of the thermal band. And that's very advantageous of 3D. But I also feel like this is also too much and you cannot.
Okay.
Because you'll always be looking at a perspective, and I always feel like orthographic gives justice to every feature.
Okay. What about both together?
Both together would be good.
Does it do anything interesting? Like,
I don't know how much worth it generally the 3D model is.
not that much work.
Like I've always found too much information is bad for general people.
Hmm.
But like if you give me a thermal image and if you give me like just beside it RGB imagery, I'll be able to pinpoint seeing what's hot, what's not.
Oh,
Like,
right next to each other.
right next to each other. And the 3D model would be everything is going on. If you make an animation, people will know, but you'll still be not looking at a particular object.
Yeah,
Places behind the trees are not visible right now in this perspective,
yeah,
and when you go behind the trees, these huts will not be.
yeah, that's interesting. I haven't really thought about the importance of showing RGB next to the thermal imagery, but I think that that's a good point.
In this, everything looks like red or blue smudges, the orthographic photo.
Yeah,
That's the only downside of the 2D orthographic photo according to me.
okay. Addison, what do you think?
I think I agree with that. I really like the 3D model. I think that it almost like you focus on like the small picture and like the fine details really well. Like I don't think that the 3D would be useful for like an area that's a lot bigger than this. Like I think it would be good for like a small area, like kind of what you have mapped out here. But then if you were to like look at a larger area, you could like show a little subset of what the 3D looks like and then show the like orthographic of like here's the whole thing.
Okay,
This is a similar question I had when one of the people at ASU had presented a digital twin about thermal models.
oh, somebody at ASU did?
I can pull up his name, but what he was doing was generating very high resolution thermal imageries using drones.
Oh, wow, I didn't know that.
Let me see. I probably can pull it right now. And I was like, okay, but why? My idea is like 3D models are to show different level of details in many dimensions. But for thermal things, I don't know if you need to do that.
I'm gonna make a note here. So Addison, you talked about scale,
Mhm.
like appropriate for maybe a certain size. Which is a good comment. It's something I hadn't thought about. In fact, Gunjan and I have been interested in sort of like taking, Gunjan and I have been sort of talking about trying to like, you do a drone scan, you build up a sense of like what surfaces do what, and then you use that to sort of like extrapolate and figure out the bigger city instead of like actually capturing all the data. But the implicit assumption there is that it would be a good idea to look at a city thermally at that resolution, and that might not be true. Hank, what was the thing that you said was? Oh, the RGB paired with RGB. That was. And I totally agree with that. This is another case where Lindsay and I have spent a lot of hours at this park. I know exactly what all of this stuff is. And so, my brain is filling in all the details of what I'm looking at. But I expect that's probably not true for everybody. And then you've got somebody from
Temple University.
ASU.
His name is Jiao Jiang Li.
ASU. How do you spell it?
XIAO GIANG LIE.
LA. You? LA. Okay, cool. So now, perfect. Thank you. Did I spell that first name right?
XIAO
Yeah.
J.
Is that a J or a G?
J.
J. JIANG.
And XIA, not E. but A.
That's it. XIAO. All right, thank you. This is great. In fact, we probably should see Gunjan's paper is. We got feedback on that this last week. I guess I didn't share that news. It got major revisions, which is actually a super good result. So when you submit an article to a journal, they'll come back and they'll say accepted with no revisions, and that never happens. They'll say accepted with minor revisions, which means the reviewers have found a few things that you should fix. Not so bad. That almost never happens. Much more common if you're going to get anything accepted is a major revision, which means they give you a list of like, here's all the things we didn't like about it or didn't change. And that's what Gungeon got. That's super common, and it's a super good result because it means that the journal is sort of tentatively accepting it as long as you make those edits. So it's really, really good news. They can then reject it, which is obviously bad and no fun. They may include a lot of comments with that. Things will get rejected if they really think that there's not a reasonable way that you can prepare the paper, or it's not of interest to that journal. And then sometimes they'll do a revise and resubmit, which is like somewhere in between those two, where like a major review, like they're not really saying that they're going to accept it, but they're saying like if you wanted to try again, like maybe they think the topic is interesting, but the work you did on it, there's a lot more work than you could do in a month. Like it's a much bigger project than that. So, anyway, good result for Gungeon, but we may want to refer to that paper. You want to try to cite as many people in the field as you can. I spent a little bit of time, not a lot of time with this. This is Facebook's or Meta's new tool called Segment Anything. There's some really neat stuff in here. There's a GitHub repo. Facebook is doing a pretty good job of trying to get their stuff really out there to researchers. So they've got a pretty big AI group out, and they're trying hard to connect with researchers, competing with like OpenAI and whatnot. This is I forget his name, Qiusheng Wu, who's at Tennessee, and he does some really awesome stuff. Way well connected to stuff that we do in the lab. I'm often bumping. I've never met him, but I'm often bumping up against cool stuff that he's done. So he had the Segment Geospatial, which basically does what Segment Anything does, but it's sort of geared towards geospatial stuff. A bit of kind of like a wrapper more than anything else. This was an interesting paper called Segment Any RGBD that tries to segment a rendered depth image, so something that you might get off of a LiDAR or something else, and tries to segment that into its constituent parts. It operates on an image that's been essentially color mapped. So they apply a color map to the depth image. That's a little less interesting to me, but still kind of neat. And then this was HuggingFace.co, which is a lot of the models that people were making. I think I saw one of these, maybe this one. The trial was posted on Hugging Chat, which I hadn't heard of before. So yeah, kind of a neat. No, not this one. That's something else. I think some AI model that I was interested in was posted here. I mean, I think was one of the geospatial ones, and it wasn't all just chat. So I don't know why I guess chat is just an example. Anyway. Shashank and I met on Wednesday. We updated the to-do list. The failure on Monday was kind of a rough one. It failed at about 8:30 in the morning, according to the log. I got the note at 9 o'clock that day and started to peck at it, and it started to, the usual approach is just reboot it and restart it, and usually it comes right back online. In this case, it didn't. And so it took some time to figure that out. The first thing that I noticed when I was looking at it was that the PTP, the precise time positioning protocol, wasn't working. So I thought, well, we planned on switching this to NTP anyway, so I just switched them all to NTP. It still wouldn't. The NTP worked, but it still didn't start. And that's when I figured out that 106 had been shut down. And so that's on a hard light switch, which is just the thing we didn't know. Like, we plugged the unit into like a outlet in the ceiling, and it turns out that outlet is controlled by a switch, which we knew because this happened at Christmas time, I think. So I messaged Kevin, he turned it back on. I still couldn't talk to it. So I went over there and confirmed that it was on. But couldn't reach it via the GUI, but then I could ping it if I was on the local subnet. And then I used the Python Blickfeld scanner library to just like initiate a connection. And at that point, it came alive. So we'll keep that in our back pocket about, I don't know what it was, like there was, I have no idea what the root cause of it was, but talking to it in Python seemed to wake it up. The three things that we had talked about on Wednesday, Addison, we found I was actually looking for the tool to apply deep learning to tabular data that I want to have you work on. Maybe you've done a little bit of that already. While doing that, we found a tool that ARC has for running deep learning models on video, which was really just kind of a nice way of annotating some of what we need to do. I mean, video is just image frames, so that's not anything in particular, but it seemed like a good workflow. Are you going to present on that today?
A little bit.
And then I had an idea, which was, again, kind of looking through that list. ARC has some deep learning tools to apply to point clouds. And if we think of time as the third dimension in our point cloud and the percept points that come out of that, maybe we've got an opportunity to use some point cloud-based processing tools on the percept data in an interesting way that would classify them. I don't know if that's going to work out or not, but it might. Those kinds of tools, ARC, Esri says that they're particularly good at finding things like power lines. And if you think of like the trajectory of a person going through space, you can think of that as a linear like feature. So might work. My baby is due on probably Wednesday of next week. So if you guys want to meet, I would encourage you to do that. And if I am able to join, I will, but I may also be tied up. So we'll see. A lot of personal business going on this week. I got to sell my house. So that's going to take up some time. So the long and the short of it is I'm probably not going to get a heck of a lot done over the next week. But I will get as much done as I can. I'm still trying to work on those papers. My goal today is to start the revisions on Sam's paper. And if I can crack those open and like do any one thing, then I'll be on the road to getting this done by, my deadline for that is June 8th. So should be good.
Have you settled on a name yet?
No, we've got it down to 5, 6.
Okay.
Yeah.
Cool.
And that's close enough. We're gonna meet it and see what we think and then make the final decision at the hospital.
Awesome.
I think we know we've got a couple that we're leaning towards. So yeah, probably one of those.
It's so exciting.
Thanks. We're excited. All right.
For today, so we were working on the percent configuration stuff last week. As and I did some changes, but I'm not able to find the screenshots anymore. So Dr. Ping and me tried this again, and we were looking at different parameters we could change. And I think we've settled on this, but we're still seeing the change from 0.25 to 0.17 on the minimum weight threshold, showing at least a couple of objects every 10 seconds underneath the staircase. So we might want to look at this again. And the thing we decided was to like actually go to the CID, move, and see if it detects like our movement. I think this is a good idea to
That's
see
good.
these parameters. And both times I worked on this, Percept kind of gave up like after 6-7 edits. Even when Anderson and I were working, like it could not get the project, and when we also did that, so we were talking about how we should define a plan before trying anything out. So I looked at everything, and I think these 4 things are the things I want to change. Maybe the threshold we have already got on that, and the other 3 I want to change them. I'm not very excited about the linear acceleration noise, but the other 2 things, the noise underneath the stairs looks like it has a very small size and it has a very high velocity. So I think that these 3 things will like possibly get rid of those. And if Alison and I get time next week, we should probably go there and just sit there, access Percept and do a bunch of things to get it.
Yeah.
This.
I can do that.
I will, this also came up during the meeting, but I've got some notes from, that I think Axel from Blickfeld sent me about his suggestions for how it should be tuned. I just need to dig those up in a lab report, so, maybe after this meeting, I'll do that.
So work on this again, and I think this will be very promising to what we're doing. The other thing I did was 2 weeks ago, I attended a webinar on digital twins to see strategies for urban planning. I was pretty excited about this, and I thought they'd be talking a lot about digital twins for urban planning, but they kind of talk most about ArcGIS Urban, which they were planning to, like, I think launch, and they have already got some tools out. I was not very excited about the ArcGIS Urban because it's just another tool. I just wanted to see the digital twin approach for this. And what I got from this webinar was ArcGIS Urban, the people behind this are treating digital twins as informative model rather than an analytical model. So they are trying to store information in these models. They are not trying to do analysis like the ArcGIS in your stuff.
Mm.
So that was surprising to me. They did multiple polls, and most of the people were like attending that had, I think 60% voted for analytical models, while 40% were like, I want an informative model of this.
Oh,
And the people there were like, we are trying for an informative model. So this was fun. This was fun, but they delved into a lot of ArcGIS Urban too, which I was not very interested in. They probably have a recording of this. If I get my hands on it, I'll share it too.
oh, perfect.
So I'm working with Dr. Kim, and like I've done some progress on this. So I had people's home locations and their work locations, and the minimum unit I had is traffic analysis zones. So he had some codes, he had some data, but everything looked very messy.
Hmm.
So I think the RA that was working with him was trying to do coding, but they were doing the looping side of things.
Ah.
And I tried pandas, and it's really fun. Like everything we learned in analysis and everything we learned in programming was really handy in this. So I put
Always love to hear that.
yeah, it's I mean, for us, I think this is a very generic problem we look at through the eyes of pandas, and I don't think many people do. So I just took out the points. I took their home TAZs and work TAZs, and I had another shapefile that was home TAZs were no that had TAZs and latitude and longitudes. So I merged them. The other challenge the previous I was having was they had 50 different TAZ files. They had to merge them. I think they either tried ArcGIS or something. I just used GeoPandas, and it was like 30 seconds to merge them. It was pretty easy. I
Okay.
don't think that'll be that easy. So the next thing I'm doing is I'm getting from the Google Directions API home to work points and generating the best directions, best commute path, and every commute path I'm generating points for every 1 minute of commute, and in that 1 minute commute time I'm getting street view images using the Google Street View API. So this is what it looks like. It was pretty fun working with this. It just looks like a fun project now. Yeah, so that was it. Next thing I'm doing is estimating the cost of the images I'm downloading from the Directions API and Google Street View API. This is my first time working with Google APIs, but these look pretty okay. These are expensive, but look pretty okay. Yeah. So this is the video that Dr. Pringle shared about using ArcGIS to use on animations to find out objects. This example had 2-3 minute video on how to do those things, and it looked very promising. The results looked very promising, but as every Dev Summit video, the results were much better than what I did. They did not do a very good explanation of what they were doing. The first step included getting a video and generating frames from it. For some reason, I could not do it. I think the metadata for the animations we are making is the reason. But I thought I spent some time in this, but I thought this was not worth my time. And what I did was, it took like around 9 minutes to see this.
Oh,
What I did was we just had raw logs that we were creating animations from. So I just decided why not use those frames.
yes. Yes, yeah, that's a good idea.
And
Or FFmpeg would probably pull them out the same. But
I thought that would be like the same thing that ArcGIS pulls out, except it generates them as rasters. That was the one thing that confused me.
Okay, yeah,
Because our animations don't have anything, our frames do not have any geospatial data right now, geospatial metadata right now.
but we could attach it.
Yeah, we could attach it.
Yeah.
That's what I was getting at. So what I did was all the frames would be too much data. So I said, I'll annotate every 15th second. And I just copied everything. And this is what it looks like. I don't know if the colors are very visible. So I started training the data. I pulled a couple of, not a couple, like maybe 20-30 images into ArcGIS and I started annotating them. So this is a person and this is a person is what I was telling them. The one problem I had was like, how do I combine the trained shape files? That's the confusing part.
Yeah, that's you to think. Yeah, if you do it this way, there's a good chance it's going to get decoupled from your. You won't be able to put it back.
That's what I was thinking. So I still need to figure out what to do exactly. So what they do is they just extract a single frame from the video, they train it on that single image, and they show the results. There's like the process between that is like I could not find a good instruction.
So, okay. So one thing that I would do is I would make a shorter video, right? So you don't want it to take 9 minutes while you do this. You could just combine some 100 frames, right? Start there and then try to figure out what doesn't it like about those images. When you encode it, it could be like it was complaining about metadata. No metadata stream found in video.
There is no metadata to export.
I don't know what metadata gets embedded in a video anyway. Metadata stream.
I'm not sure. The only thing I thought of was the video they have is of a lake or something, water body, and it probably was taken from a drone. Drone basically attaches the GPS data on
It doesn't, not to the video.
not to a video.
Yeah.
Then my logic, I don't have any answers to that at all.
Huh. So another thing that you could try is like if you just record like a short video with your phone, like does that run? You know, like you can't do anything useful with it, but at least we could see if like does the tool process it. So two strategies for you. But yeah, I think even though we do have access to the raw data and you could annotate it the way you did, I think it's likely to cause extra problems for you down the road trying to merge it back together again. Because their video wouldn't have been geolocated anyway, so they have to somehow not care about that.
That's what I exactly thought. So in one of the steps, they say annotate to everything and then export every image you have as a raster. So I thought their image is also a JPG. And they export it to a raster later on. So that's what I was trying. But one contextual problem I was thinking about is like, do I have if I have 15 frames, do I have 15 annotation files or just one annotation file? Like the data.
Yeah.
So that's something I could not wrap my head around because if I remember correctly, the image analyst tool only requires one annotation training data.
Yeah, I don't know. Yeah.
I still need to I'll probably work more on this.
Okay.
So this is the problems I had. And we were talking about dividing the CID space into major zones last week, and Dr. Pingle showed me two good papers that I really like reading. And one of them is Where's Downtown by Montello and Wichal and everywhere else. So this paper talks about how people think differently about spaces, about boundaries. And the paper basically uses downtown Santa Barbara as a major example and they run an experiment on people's idea about where downtown actually is, what's the core or the center of the downtown, and what's the shape of the downtown. So it investigates how people interpret spatial boundaries. This was really fun. This was a very good read. And the survey they conduct works on three major questions. One is, what is the shape and size of downtown Santa Barbara? The second one is, where is Santa Barbara downtown? And the third one is, what is the central location of the core of Santa Barbara? And the people they talk to are actually in downtown while they are conducting the experiment. And the major thing I liked about this is the concept of vague spatial queries. where we use, like, not in an informal setting, we always talk about, I'll meet you near this place, but what's the concept of near? While the formal arguments of geography has always been very physically like signified, like the boundaries are very well established, and the GIS models and the GIS models are always very distinct, have always had distinct boundaries, whereas people's interpretation of space is not always that, and that gives rise to the fuzziness of boundaries. So even with the familiarity of the space, people have different ideas about where a place is actually bounded by spatial region. So this paper also had ideas about spatial cognition of normal people. So people normally use landmarks and street patterns to identify the concept of boundaries in downtown. This was really good, and I think for our case, I try to relate this with what we think, and I also think Dr. Bringer and I talked about overlapping zones, and I think that will be a major issue because people will have different ideas about what a particular space is, the concept of meaning to that zone.
Yeah, let's expand on that because that relates to your work, Addison. When you mapped some places over at CID, I think the idea is, polygons. So first of all, we operationalize these as polygons, right? Which is itself a little strange, right? GIS people get used to sort of like thinking in terms of polygons, but that's really just a total fiction, right? Like these boundaries aren't solid boundaries; they're fuzzy. And then the second thing is like this area may well overlap with that area, right? So if you do the zone-based analysis, there's no reason why things can't overlap. So yep.
And depends on the perspective of people using that space. And the next paper I read was from UPOP 1, and it talks about the UGCOP, the uncertain geographic context problem. This was kind of an addition to the previous paper, and this talks about how every GIS problem is associated with two major things. One is modifiable areal unit problem, where every analysis in a geographical context has been bound, like the definition of what the boundary is, should neighborhoods be identified as something that defines a location, should counties be. So that was the major problem identified in previous GIS research. The next thing that MAPOP1 adds to this is the differences or deviation between the actual geographical delineations and the two geographic contexts. This is something I think is very interesting to precise geographic delineations of contextual units and its deviation from the true geographic context. I think the second point is more subjective than what we're used to in every GIS analysis. We normally do not think of this as much. I think one of the examples that MAPOP1 gives is about the voting analysis, and she says something like, if you define a boundary, the people at the edges kind of have a disadvantage on the analysis because they are also one of the major findings of this paper was people spend more time within a 1 kilometer radius of their home. So just defining people by their home locations is not a good idea.
Oh yeah.
So that was very.
It's all a bunch of overlapping zones.
Yes.
Yeah.
And even the concept of seeing people's locations is added to this using GPSs because they travel to work and they're influenced by people around their work. So that was really neat. So defines the problem as a challenge of accurately defining and measuring contextual units. In our case, I don't know what that will be. We just thought of dividing the zones, but I don't know now that it's a very good idea.
Yeah.
And the paper adds to the capabilities of GIS, saying that one concept I think I missed was the concept of egohood. So egohood is the concept of a person being identified as its own boundary. So we just take that person and sketch that person around, like where he moves and stuff, and that's a single boundary. That's a single zone. And I don't know, that seems interesting to me, but I don't know how to use that because it would be a lot of boundaries or a lot of overlapping boundaries.
No, that would be, yeah, I mean, that's an interesting thing to think of because our data doesn't allow us to do that, right? But if we could, what if we knew the spatial tracks of every person that went in the CID and did anything? Like, what would that? How would we? How? What analysis would that facilitate? What could we do with that we can't do with what we have now, where we don't know the difference between one person leaving and one person coming back?
I thought like because we are looking at the aggregate behavior
So far,
so far. I don't know if we want to look at individual contexts.
we do. Yeah, we definitely do, and that's where I think, Percept, or like the data that comes out of like the OpenCV based analysis is going to be really useful. We still don't know that there's no difference between a million different people using the space and the same 500 people using the space. I think that would be a good thing to think about. What, just as an intellectual exercise, what if we did have
Like
everyone's unique ID, and every time Fred goes through the space, it's always tagged Fred. What would we learn, and what would we know, or how could we analyze the data differently?
One question we had at OGIS was like I don't remember her name, but she said, "Can you differentiate men and women?" And she said like gender-based usage of this space is also very important in certain questions.
That's interesting. Yeah.
I'm not sure about the
Ideas?
You could like try to go off of like a maximum height type, and it would just be like a generalization, which would obviously not be super accurate. But I don't know if like our resolution is high enough to like actually capture like high enough quality differences like physiologically.
Oh, this is interesting. You remember who it was that had that question?
I think she's from the Eleanor's lab group. Do you remember she's from AEC? I forgot her name. She was just next to our poster.
Oh, like was she presenting next to our poster?
Yes.
So one thing that I can think of is we could immediately sort of land ourselves in a little bit of hot water by,
Yeah. That's immediately what I go to also.
Yeah. But I think the question is interesting. Suppose we can do that with some degree of accuracy, right? Like there's gonna be error. There's gonna be error in how the thing works. There's gonna be error in, physical appearance and gender. But if you could, well, I mean, one of the things that we had talked about at one of the meetings, I don't know if we shared this with you or not, Shashank, but we had talked about doing an analysis of residents versus non-residents.
It also comes to my mind, like talking about how students use that versus staff versus faculty versus the people passing by.
Yeah. The resident, non-resident, we had a couple of ideas for operationalizing. One was just as like a first cut, send somebody by 1 or 2 times and just ask everybody that's at a table or wherever, are you a resident or non-resident? Like, we don't care either way. We're just like kind of, and so if you found, for instance, that residents cluster here and non-residents cluster there, you could definitely see potentially a space signature of that. I don't know. Do you think that we would find a spatial signature of gender in the space?
I'm not sure. I think the residence thing is really interesting, actually. I could imagine that if you could tag like entry points as like basically if someone comes in through like a outside, oops, actually, if they come through like an outside facing door and then leave through that outside facing door without being dropped by the sensor, they could be like an outdoor, like a non-resident.
Oh yeah, they come in and then they leave. They don't go into the building. That's a good idea, honestly.
Which is like, that's the way that I could think that you could do that.
Yeah.
But you would have to have the like they would have to be a single track the entire time because otherwise it would like drop their signature and
That is a really good idea. So one of the other ideas that we had for measuring that would be staff has all of the Wi-Fi. And so we would kind of know like who's in the building at 3 a.m. routinely and who's not. And so we would be able to tell by access points, not like locating them in the space, but like of all of the users,
How many I go?
how many of them are here, typically here at 3 a.m. or not. And that would be, I think that would give us a neat aggregate that we could use to compare the resident, non-resident source and where they come in and where they go, and as a way to identify that. That's very clever.
I'm sure residents have like a specific signature.
I bet they do. Huh. Addison, do you have any interest in following up on this, or are you still pretty committed to the weather idea?
that would be interesting for me to follow up on. I'm not like super committed to anything too specific yet. I guess if Percept could classify like a stream well enough, although it wouldn't necessarily have to be Percept, you could do it through the OpenCV2 possibly. Because that would be interesting to see how like do people who come into the building use the tables closer to the exits.
Totally. And it really directly gets to like the sort of this idea of place and meaning, right? Like people who live there use the space differently than the people who don't, and have these kinds of patterns. And it would go beyond sort of the, because I don't think I know what the answer to that is, right? Like I could see it either way, and so it would be interesting to know. Let's spend a week on this, Addison. Just kind of roll it around a little bit and see what you think, and let's talk about it next week.
Sounds good.
Even if it's just operationalized, right? Even if you're like, we're just going to assume that anybody coming out of this area is a resident, because like this is where the residence hall is, or at least like at certain times of day, right? Like we might have to
that's a good way of doing it.
look at classes and stuff, right? But like if you're coming down out of that elevator, or you're coming down off of that hallway, like you're almost certainly a resident. At least within the noise, right? Like all of this stuff subject to error. But I think probably that would sort out well.
You could at least by doing that break it into like definitely residents and then like unclassified.
Yeah. And you could, you know, I don't know how many people Tim knows, but if you sat down with Tim or Kevin for like half an hour, and Kevin was just like, oh, that guy lives here, that girl lives here, that person lives here, we could test the theory, right? Like, and they might say, I don't know, but you could make a tally mark and see like how many people coming out of that hallway or whatever we think these origin points are, and then take it a step further. We could ask, right? The next thing would be, all right, we think this is going to work. Just like sending somebody around the tables, we could just like randomly ask every fifth person that comes down the hallway, like, are you a resident? Are you not a resident? We'd have to, I mean, obviously that would have to be all IRB'd and whatever, but like, is it possible? Could we, because then we would have something that sort of says, all right, we're going to operationalize this with the Percept data. We think this is going to work. Here's why we think it works. We did a little pilot study, and we, you know, we're pretty sure that this is accurate to within this number. So here we go with our analysis based on that. Yeah, very good. Sorry, that was a bit of a diversion.
Yeah, that's a nice resolution. So both of these papers I thought looked into the qualitative aspect of people associating with a particular boundary, and that I found really relating to our project. And when we define that those boundaries, I think this was going to be a very good literature to look back upon. So the next week I did not update the rules, but think I might have. So, finish the deep learning using animations. I think I'll probably figure out something. I'll probably move forward with that. I'll use a shorter video, as you said, and I'll try to figure out the metadata part of it if I can. The next things I'm going to do is experiment with Percept regarding the parameters. And I've got a bunch of other lists, but these are the two things I'll probably focus on next week. And for the summer work, I'm going to start downloading a few data sets and see how expensive those are. And the third one is I submitted a student waiver form, and since they extended the deadline for the abstract submission, they will only send back something after a week. So I'm still waiting on that, and I'll register for this before the deadline of 29th.
Okay.
Yeah. So that's it from me today.
I have one, so I can share once that's open. Okay, let me try this. Yeah, so I have a pretty quick one this week. I wanted to work a little bit more on the Percept data, like getting it to work in the space-time cube. And then just like a little recap of what we did for the Enterprise GIS coursework. So when I was trying to do this last week with the Percept data and getting it to like work in the space-time cube, the main issue is that like ArcGIS shape files have like a super specific date format. And I think there was a third, but generally they have to be in like a very specific, like two digits for month, 2 digits for day, and then either 2 or 4 digits for the year. And the Percept data has this like timestamp. And when we write out this timestamp, but the format of the timestamp is not supported within like a date format field within ArcGIS Pro. So when you go to make a space-time cube, you're like, it'll ask like what the field is for the time. And you'll like say it's this field, and it will tell you like, oh, that's not the right format, or like that's not a date format field to do that. So I guess my proposed fix, and this is just kind of, I think, a temporary fix, was just using Python on the shapefile to like go through a certain amount of each shapefile and basically just like create a arbitrary month, day, year, date field for like each like percentage of the shapefile. So for like the Python code that I wrote, basically the input was like a single shapefile of like the Percept points. So the purpose of the code, is just basically taking a specified percentage of the shapefile and then writes out like a new date format for each shapefile, or for each like percentage of that file. So if there's 24 hours worth of Percept data, and you have your like in value and the code be 24, it'll go through like 1/24 of the data and say, this is April 1st, 2023. And then it'll go to the next 24th of the data and say, this is April 2nd, 2023. So the dates themselves are not actually representative of what they would be. It's more of just like an index of like, in this case, it would be hours. So yeah, for this, you would only have to change basically the file name, the input shapefile of the Percept data, and then the number of like percentages you want to go through. So for this one, I think there were like 6,000 objects. So it would be for like every 651 objects, it would like make a new day. So then this is the code that I have to do that. And then within like the Percept data frame now, like the first couple have the like 04/01/2023, and then the last couple have the 04/10/2023. So now this is in like format to bring it into Arc. So I did that, and to do that, you still have to add a new date field because it imports as a data type like text. So for here, I just imported that or added a new field and called it date, and then calculated the date field to be equal to that text field. There might be an easier way to do this entirely in Arc. I'm not sure yet, but this is, I guess, a kind of a workaround of doing that. And then here within like actually creating the space-time cube, you can just specify the time field to be the dates too. And I also changed the time step interval to be 1 day. And the distance interval is 1 meter. So basically for every 1 meter, what it's doing is it's counting the number of like percept points within that data. So I got pretty good, I would say pretty good results from this. I only ran it over just to have it like process quicker and to see if it was going to work. I only ran it over like 20 minutes of percept data. So it was, there's like not a lot of actual objects in the space to create like a cube that has meaningful patterns. If I did it over a day, you would maybe see different results, but obviously that would be like a bigger shape file. But I think it looks good for only around 20 minutes of data. So there's 10 time slices within here, which are effectively 2 minutes per time slice. Here's probably the noise under the stairs, but then here's like the chairs by the windows, and you can see like someone was probably here during most of that time, and someone was probably sitting over here during most of that time. And I think that these blank spaces were ones that were not occupied at all during the entire time. So I'll have to figure out how to have the like 0 still show as like a blank cube rather than not showing at all.
I don't know, I kind of like it this way, because then you get a chance to see where there was like literally no activity.
Okay. Yeah, so I think my next step is just I want to try this for like an actual day's worth of data and break it into like 24 hours, which would be April 1st to April 23rd, I guess, or 24th. But then I think that would maybe let us see if there are like actually patterns within the data. I thought this was a good start.
Yeah.
And then just within the enterprise stuff, so a lot of what we did this semester was like working within Amazon Web Services. So we had to kind of set up these different like parameters on Amazon Web Services that run on these like EC2 computer instances, basically. So first you have to like build this ArcGIS enterprise like base deployment is what it's called. So like the actual a computer somewhere that's hosting an ArcGIS enterprise server. And you can access that on a website. And then additionally, to get that to like communicate with Percept and some of like the other things, you would have to install these like extensions. So those would be a GeoEvent server, a big spatiotemporal data store, and then also an MQTT broker or MQTT connector, which basically each one of those is the GeoEvent server helps with like real-time data processing and like analysis and visualization. And then obviously the spatiotemporal big data store is there to store large amounts of data. And then obviously the MQTT is basically just like a way to have this computer here talk with this computer here and like basically automate data transfer is kind of the way that I see it working. But I don't have a perfect understanding on how this stuff exactly works. So yeah, MQTT stands for message queue and telemetry transport, and it's designed for data transfer between devices. So within Percept, Percept has like an option to either like write out physical files or just like send the data output via MQTT. So it can like basically MQTT broker can basically receive data from Percept's output and then give it to our like ArcGIS Indoors enterprise system. So within AWS, Seth created one. I don't know if it's there anymore because, well, it's probably still there, but it's probably not running. But I'll get to that in a second. So yeah, I think Percept can basically in like the Percept configuration settings, there's a setting that's like sending output via MQTT, and you can like specify basically the IP address or the MQTT broker name, and then the port that you want to send, I guess, automatically like transfer the data over. And then like that kind of allows the data to be connected to the enterprise system a lot easier rather than having to continuously go forth to like download data from Percept, upload it to ArcGIS Enterprise, download more data from Percept, upload it to ArcGIS Enterprise. I think MQTT is designed to like do that all in one step. So then doing that on AWS, we created a lot of these resources with Seth's help, but basically had it running on these like EC2 instances. So for the class, we had two websites. So the first one is this like main website, and then the second one is this indoors website. They're both turned off at the moment, which you can see like these are the EC2 instances on the right. And the instance state for all of those are stopped, which means that Seth turned them off. They cost a lot of money to like actively run. So if we're not like currently actively using them, then it makes more sense to not let them run and just have them be off for the time being. Yeah, that's all I have for that. So my next week's goals are get working on the proposal, figure out what exactly I'm going to decide on researching, and just like read more papers, get some of like the literature review stuff covered. And then I also want to work more with like some of the noise classification and Percept. So Shashank, if you want to go to the CID building at any point next week, I should be able to do that.
Let me ask you a quick question about the MQTT stuff. So I'm not sure that I totally understand the end point of how far you got. So we know that Percept can send out its data, MQTT. Did you get them linked up? Like,
We did not. So what happened with that was like the base deployment we created was not running. We did not manage to make actual base deployment, but Seth had made the actual base deployment we should be working on. So we did not get everything attached to the base deployment, but we have everything like as individual objects. So we have a base deployment, we have ArcGIS, spatial based database control. We just need to put those things together and start like transferring data. But we did not end up like actually making it like operation.
okay.
Yeah.
So that's probably okay. I'm still interested. One of the things that I would like to maybe do is try to get all of the Percept data transmitted to maybe David Franisich on the team. So he's over at ICAT. He's kind of like a data visualization guy. I'd kind of like to see if we can like get the data to him and he can do anything with it, right? So I would put that as maybe a priority. Getting it inside Arc indoors is still of interest to me, to the extent that I don't think we've gotten as far. I don't even know where we are with indoors. The license is still not set up and we still can't do anything with it. So given everything else that we've got going on, that's not the highest priority I have. I'm still super interested. But I think just in terms of capacity, we may not be able to do it. But why don't we see if we can set something up so that we can push data to David. And that would be a good start. And we won't do the CID yet. We'll just start with like our local one. And if we can do that, then so I'll send an email out to do this for me.
That we'll just be setting up a Mosquito server and try to send GS1 files we have.
Yeah. And then for him to do
Like
anything. Like if ideally what I'm thinking is like dots on a screen, right? Like as a step one, like he'll get the coordinates, and if those coordinates can get drawn and they're just dots, like that is a fine starting point. And then we can sort of, go from there. But like we should be able to generate things like a hotspot visualization, right? Where we may not be rendering every point that we're getting off of Percept, but like these are the area, like that would be a good data visualization, like a real-time hotspot map of like what's going on in CID would be neat. And then if we ever do get ArcGIS indoors set up, pulling those in and then overlaying that on real time, because again, Seth's Wi-Fi data, I'm not sure how much he publishes that, maybe you guys know, but I think that he's able to basically provide real-time estimates of like how many people are in a building.
Yeah, he has been talking about that like multiple times.
And, you know, it would be interesting to compare like just that number against, and this is probably something that we should do, is like getting that data and then relating our OpenCV data or Percept data and sort of plotting those together, right? Like this is our activity inferred from Percept. This is our activity inferred from the raw data logs. And then this is our activity, you know, this is our activity inferred from the OpenCV processing of those data logs. And then this is the Wi-Fi. And like, you would want to see all of those things kind of
Together stacked on.
hanging together. So that's probably a thing we should shoot for. I'm trying to, you know, I guess I didn't put this in there, but I want to get a report written. We have to provide a report to the NSF not later than July 1. So I'm going to be working on sort of our part of that and just brain dumping everything. They don't have to be super, nobody's going to read it. It's just a thing to get done. But if we can not worry so much about formatting, but do try to get all of the details down, I think that's a useful exercise. And I would be interested in getting something like that, like a plot like that in there. I also was thinking this morning about, I'm not sure what our current state is of like ways to digest the plots to produce the plots. You guys did it for your poster. I need to sort of refresh my memory about what you did. But like, what do we think is our best method of visualization of activity from either our aggregate data or from the NetCDFs?
So the data we got were from NetCDFs, and we were trying to like get a single number from each hour. And that number would be an average of activity over that hour.
Yeah.
And what we were confused about is the numbers did not seem similar for different days.
Yeah. So
we were trying to normalize it.
Yeah.
And the major two questions were, do we normalize it throughout the week? Do we normalize it over the day?
Yeah, I mean, in terms of that visualization, I think I think normalization is probably a patch rather than a correct digestion of the data. So I'll try to sit down with it. I'm more able to ask you guys questions once I've spent some time with it. So let me spend an hour with it and see what I can come back to you guys with, and then we'll see. But ideally, you know, we really should be able to pull out that number or a number that makes sense. And I'm not sure. I think we're probably going to, by the way, need a submask. Like, I don't know that we're ever going to extend into that southern hallway. So I think maybe we might just create a second mask that's sort of just like basically your mask Addison, but like with that southern hallway like X down, because that data is so unreliable, it's not even worth counting in a lot of, at least I don't know. Maybe that's not true, but anyway, still lots to do. So hopefully we're past the relaxation point and we're back into work mode. There's a lot to do over the summer, so, but very good stuff. All right, let's stop the recording. Addison, when are you back in town?
I think I'm coming back tomorrow.